Welcome back. This is an Aleks training video on diluting a strong acid solution to a given pH. So a strong acid is anything that will completely dissociate into protons plus its conjugate base when you put it in water. So even though that it's a covalent bond, it's not an ionic bond, it's not like a salt that dissolves, but if you put a strong acid, all of it will dissolve or dissociate, not dissolve, dissociate into hydrogen ions, H plus whatever the leftover is. Okay, in this case, you have an H plus nitrate, NO3. So when that happens in water, you're always going to get the H attached to water itself. So this hydrogen plus will join with water that it's in and form hydronium. And then the leftover of whatever's left over here is the nitrate. Okay, so you are asked to know what the concentration, in order to answer this question, you need to know what's the concentration of this. We want to know the concentration of that. All right, so if we want to know the concentration, then you're going to need to remember that the concentration of H3O plus is going to be equal to 10 to the negative pH. 10 to the negative pH. So when you have a pH and you're trying to find the concentration of the hydronium, you make that pH the exponent of a 10 to the negative pH. And then that number is your concentration. So we need to find this concentration because we're eventually going to need to know its molarity and then the number of moles so that we can dilute it down. So we need moles. All right, so if we're going to do that, you're going to, it gives you a pH. You're going to say that this is going to be negative 10 or 10 to the negative 1.5 because they need you to have a pH of 1.5. So if you do that, 10 to the negative 1.5, you put 1.5 on your calculator, give it a negative sign, and then hit the inverse log button or the second function log button, 10 to the x key, and you will get 0.031622777 molar. Okay, that's the concentration, the molarity of that concentration. So if you remember what molarity meant, molarity equals moles over liters, moles of solute over liters of solution. So in order to dilute this, we need to know how many moles of this stuff we need. So we've got the molarity and we've got the liters. We know how many liters it is. So we're going to multiply molarity times liters. Well, the liters they're going to give you as, they say it's 400 milliliters. So that's 0.400 liters. So we're going to have 0.4 liters times what you just found in molarity, which is 0.031622777 molar. Okay. When you get that answer, multiply it together, you're going to get the moles. And this is 0.1264911 moles. So that's how many moles of stuff that you need, okay, of this particular nitric acid. Well, don't want to know just moles. I need to know how many liters of it is. How many liters do I need? So the way I go from moles to liters is molarity. The molarity of the stock nitric acid solution is 9. So I'm going to divide by the molarity. So I'm going to take the number of moles, 2649111 moles, and I'm going to divide by the molarity, which is 9.0, and the molarity is moles over liters. So the liters are going to go on the other side. Moles will cancel. And when I divide that out, I'm going to end up in liters. I want milliliters. So let's just go ahead and divide or multiply. In 1 liter, there's 1,000 milliliters. So liters are going to cancel. I'll be in milliliters. So 0.1264911 divided by 9 times 1,000 is, how many significant digits do I need? I need 2 significant digits. And that's going to give you 1.4, okay, mils. So I need 1.4 mils of the stock solution, and dilute it by putting it in a flask and then filling it up with distilled water up to the 400 mil mark. So that's a dilution problem. Pretty involved, but if you do this several times, I think you'll get it, I'm sure.